Okay, good evening. So we're going to make a start. All right, so we can see on the screen, I'm not sure if you could see this before or not before I started the meeting, but hopefully we could, that there are 6 different types of sequences on there. So this evening we are going to look at some sequences, and we're going to look at finding the nth term of sequences. And we're going to look at this both at foundation level and at higher, although it's a very good topic to do because the foundation does link into the higher topics. So it's a good sort of topic to be able to do, where we've got a range of different abilities, both for people sitting in the foundation tier and the higher tier. But both tiers need to be able to identify different types of sequences. So as I mentioned previously that this was a past exam paper question, and this was worth 4 marks at the time. So it's got 6 sequences down the left-hand side, 6 different descriptions down the right, 6 different types of sequences, and we just have to match up one to the other. It gives us one for us, so it tells us that 1, 1, 2, 3, 5, 8 is a Fibonacci sequence. Okay, so it tells us that is a Fibonacci sequence, and we are expected to know that the Fibonacci sequence is 1, 1, 2, 3, 5, 8. And to find the next term, you add the previous 2 together. So 1 add 1 is 2, 1 add 2 is 3, 2 add 3 is 5, and 3 add 5 is 8, etc. So that is the Fibonacci sequence. You might get given a Fibonacci style sequence, which would follow the same pattern, but would start with different numbers. But that one there is our Fibonacci sequence. Now, if we were going to match up the rest of these here, okay, the first one, 1, 2, 4, 8, 16, 32, is what's known as a geometric progression. So the geometric progression is where we multiply or divide by the same amount each time. So we can see as we're going through there, we're doubling each time, 1, 2, 4, 8, 16, 32. So we are multiplying by 2 every single time. So that therefore is a geometric progression. Our next one, 1, 2, 3, 4, 5, 6. Well, that's just going up by 1 each time. And if we've got something that's going up or down, we're adding or subtracting the same amount each time. That is what's known as an arithmetic progression or an arithmetic sequence, or sometimes even known as a linear sequence. And they're the sequences that we're going to start by focusing on today, looking at those linear sequences, those arithmetic sequences, and finding the nth term of those. Our next one, 1, 3, 6, 10, 15, 21. Well, that follows a bit of an interesting pattern there. So we've got 1, and then we add 2, then we add 3, then we add 4, then we add 5, then we add 6. So those numbers there, 1, 3, 6, 10, 15, 21, is something that not many students actually remember, but they are known as our triangular numbers. So 1, 3, 6, 10, 15, 21 are our triangular numbers. And they are actually forming in a what's known as a quadratic sequence, which is what we're going to look at for the higher students a little bit later on. The next one, 1, 4, 9, 16, 25, 36. Hopefully we should spot are our square numbers. So 1 squared, 1 times 1 is 1, 2 squared, 2 times 2 is 4, 3 squared, 3 times 3 is 9, etc. And that leaves our last one, 1, 8, 27, 64, 1, 2, 5, and 2, 1, 6 to be our cube numbers. So we can see there 1 cubed, 1 times 1 times 1 is 1, 2 cubed, 2 times 2 times 2 is 8, 3 cubed, 27, etc. Now, if I was faced with this exam question here, I wouldn't necessarily go down the left-hand side and do them in the order that I've just gone through them. So I might not necessarily know some of them straight away. So I'd have a look through and I'd do the ones that I definitely know. Hopefully we'd be able to spot the 1, 2, 3, 4, 5, 6 as an arithmetic sequence. Hopefully we'd be able to spot that our square numbers, we should know those, and our cube numbers as well. We should be knowing those off the top of our heads. So we should be able to know those. And then once we've filled in maybe some of the ones that we can do, it's a little bit easier. It gives us more of a chance of, even if we just have to guess the other ones, it gives us a greater chance of getting them correct. So going through and doing the ones that potentially we should know first would be a good idea there. Right, so there are different types of sequence. So we're going to focus today, we're going to look at linear sequences and finding the nth term of linear sequences for foundation. And then we're going to move on and we're going to have a look at quadratic sequences for the higher. But the linear sequence that we're going to start with forms part of finding a quadratic sequence for the higher, so it does follow on quite nicely. So it is important that if we're doing the higher, that we can do these first ones off the bat, because it forms the second half of the process to finding a quadratic sequence. So what we've got here, foundation, we might be asked to find the nth term of these sequences. So our first sequence says 8, 13, 18, 23. Now, every time we look at a sequence, naturally our human instinct is to look for that pattern. We do find that sequences are a very well sort of answered topic within maths, mainly because it's human nature to try and spot patterns in things. So the very first thing we're going to do is we're looking naturally for a pattern in that sequence. And it doesn't really matter what the question's asking you for. You've still got to spot that pattern. Even if it asks you for the term-to-term rule, so what is happening each time, if it asks you for the next term, so the next number in the sequence, or if it asks you for the nth term, the first term bigger than 100, any of these sorts of questions that could come up, the very first thing we need to do is to spot that pattern in there. So we can see that going from 8 to 13, we had 5. Going from 13 to 18, we had 5. And going from 18 to 23, again, we had 5. So because we are adding on the same amount each time, that tells us that this is a linear, or as we've just called it, an arithmetic sequence. Now, when we're finding the nth term of an arithmetic or a linear sequence, as we are here, it's always going to follow the same form. So it's always going to be something n plus or minus something. All right, so every single time, it might be something like 7n plus 2, or 10n minus 8, or minus 4n plus 62. Something in that form. All right, that's the form our nth term is going to take. It's always going to be something n plus something. All right, so there's going to be two numbers there that we need to find. Well, naturally, we're going to see what it goes up by each time. So that's going to make one of those numbers. So as soon as we're looking at that sequence, we should be able to spot that pattern. And if we can get that number in the right place in our nth term, that's 1 mark straight away. So because this number is going up by 5 each time, because this sequence is going up by 5 each time, that tells us that we're going to be looking at 5n. So whatever that sequence is going up or down by each time, that is known as our coefficient of n. That's just the number in front of n. Now we need to figure out what is next to it. And we've looked at this in lesson quite recently, and we sort of like link it to our times tables. And there's a couple of ways to do this. So you can either think about your 5 times table in this case, 5, 10, 15, 20, and see what you need to add on to those to get to our actual sequence. Or to get from 5 to 8, we'd add 3. To get from 10 to 13, we'd add 3. 15 to 18, add 3. 20 to 23, add 3. The other way to do it would be to go back 1 in the sequence, just to think about what would come before 8 in our sequence. Well, to find the one before 8, we'd have to take away 5, and 8 take away 5 is 3. So we can add that number onto the end. All right. So a couple of different ways to find that second number, but that would be worth 2 marks in your exam. You'd get 1 mark for your 5n and 1 mark for your plus 3. So straight away, natural instinct, spot that pattern. What is it going up or down by each time? In this case, it's going up by 5. So that's our number in front of our n. So it's going to be 5n. What number comes before 8 in the sequence? That is 3, because we have to take away 5 to get the one before it. So that gets us 5n plus 3. Now, the second one, slightly different. So this time, again, we're going to look for that pattern, because it doesn't tell us that it's a linear sequence. If we were on higher, it might be a quadratic sequence that we have to find. All right, so we have to start by checking out that pattern. So we can see that to get from 2 to 6, we add 4. 6 to 10, we add 4. And 10 to 14, we add 4. So we are adding 4 each time. So it is a linear sequence. So in that case then, because we're adding 4 each time, that's going to be the number that goes in front of our n. So it's going to be 4n. And then we can either think about our 4 times table, 4, 8, 12, 16, and think about how we get from those numbers back to our sequence. Well, to get from 4 to 2 is take away 2, 8 to 6, take away 2, 12 to 10, take away 2, etc. Or we could see what comes before 2 in this sequence. So 2 take away 4 does get us back to minus 2. So it would be 4n minus 2. So there's just 2 numbers to find there, okay? So the linear sequence always going to be something n plus something, and we've just got to find those 2 numbers, all right? And that's worth 2 marks on your exam. Now, the only place it might get slightly trickier is if we start to include some different negatives, all right? So we might get a bit of a, excuse me, a bit of a descending sequence, all right? So a sequence that goes down. But it's still going to be arithmetic as long as it's the same amount that it's going down each time, because it's technically adding a negative. So if we have a look here and spot our pattern as natural instinct wants us to do, we take away 3 to get from 21 to 18, take away 3 to get from 18 to 15, and take away 3 to get from 15 to 12. So we are taking away 3 each time, so it is still our arithmetic, our linear sequence. So this time, because we're going down by 3 each time, because it's minus 3 each time, that means it's going to be minus 3n. So if it's a descending sequence, we're going to have a negative coefficient of n. It's going to be a negative number in front of our n. So in this case, it's minus 3n. And then we still need to figure out that number at the end. Okay, well, this time, this is where it's probably more useful to see what does come before 21 in the sequence, rather than maybe thinking about our negative 3 times table. So what comes before 21 in the sequence? Well, if we add 3 to that to go backwards, that would get us to 24. So then we can add that onto the end and get minus 3n plus 24. Now, that is a perfectly acceptable answer. And if you get that question in your exam and you write minus 3n plus 24, you will get 2 marks. However, we do have to be aware that it could be written as 24 minus 3n, okay? Because that's technically the same thing, and mathematically it's considered neater. Now, the reason I mention it is because sometimes it's given in the question in that way. All right, but it's still exactly the same thing. Minus 3n plus 24 is exactly the same as 24 minus 3n. We've got to be aware that if it's written in a question, it's more likely to be written in that second way. But if you give your answer as minus 3n plus 24, 2 marks, no questions. Okay. Right, so that's finding the nth term of a linear sequence, and that's what comes up on a foundation paper. Looking there, like I said, about 2 marks for one of those questions. So what I want to do now, I've got some sequences up there. I've got some ascending ones and some descending ones that the foundation students can have a go at. And whilst you guys are having a go at that, I'm going to run through how we find the nth term of a quadratic sequence for anyone that's studying higher. All right, so if you're studying foundation, have a go at those 16 sequences there and have a bit of a practice at finding those. And I'm going to go through 2 examples for the higher. When I've done the 2 examples for the higher, I'll put the answers to the foundation questions up, and then I'll put some more questions up so that both sets of students can practice. Okay. Now, for the higher, we've got a quadratic sequence here. Now, nowhere in the question does it say quadratic. It doesn't have to tell you it's a quadratic. We have to be able to spot that it's a quadratic sequence. Now, a quadratic sequence has got the same second difference. So rather than going up or down by the same amount each time, what it goes up or down in goes up or down by the same amount each time. So let's have a look at how that works. So we've got 5, 8, 13, 20. So again, let's just investigate the sequence. Let's see what's happening each time. So we can see that to get from 5 to 8, we're adding 3 each time. To get from 8 to 13, we're adding 5 each time. And to get from 13 to 20, we're adding 7 each time. So there's not the same pattern there. It's not going up or down by the same amount each time. But what there is there's a pattern within our pattern. So to get from 3 to 5, we add 2. And to get from 5 to 7, we also add 2. Okay. So we've got what's known there as the same second difference. So if you've got the same second difference, that is a quadratic sequence. Okay. And then that's going to take the form of something n squared plus something n plus something. Same as a quadratic equation is ax squared plus bx plus c. Okay, it's following along that same form. Okay, I know we've been looking at expanding and factorizing in lesson recently. So when we're expanding those double brackets, we get x squared plus something x plus something. Same sort of concept, but we use n because it's sequences, and we're finding the nth term. Now, to get those numbers, all right, the first thing we need to do is we need to take our second difference and we need to half it. All right, so we need to half the second difference for your coefficient of n squared. So for the number that goes in front of the n squared, we have to half that second difference. So if you can remember to get to that point, and half of 2 is 1, so it's going to start with 1 n squared, or just n squared. And if you manage to get to that point, just finding your second difference and halving it, that's enough to get you into the marks there to begin with. But then what we need to do is we need to find the plus something n plus something, which is just a linear sequence, which is what we've just been talking about at foundation. So what we need to do is we need to take our quadratic sequence and we need to take away our 1n squared. All right. So our n squared is essentially just our square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. We need to take those away from our sequence. And if we take those away from our sequence, we'll be left with either two options. It'll either leave all the same number, or it will leave a linear sequence that we can find the nth term of. So if we have a look at taking these away here, so our sequence is 5, 8, 13, 20, and our n squared, our 1n squared that we've just worked out is 1, 4, 9, 16, just our square. If we take those away, 5 take away 1 is 4, 8 take away 4 is 4, 13 take away 9 is 4, and 20 take away 16 is 4. So every time there, as we take those away, we are left with 4. All right. So if we're just left with the same number when we take them away, all we have to do is to add that number onto our 1n squared that we got earlier. So in this case, our nth term for this sequence is n squared plus 4. All right. So a couple of extra bits in there. All right. So we have to start by trying to spot that pattern. So spot your first difference, and then there won't be the same thing there if it's a quadratic, so 3, 5, 7. But in our second difference, it is the same. So our second difference each time is 2. We have to half that second difference to tell us what number will go in front of our n squared. In this case, half of 2 is just 1. So it's going to be 1n squared, or just n squared. And then we have to take that away from our sequence. All right, so our sequence is 5, 8, 13, 20. N squared, just our square numbers, 1, 4, 9, 16. Take those away from our sequence, and each time there, that leaves 4. So because it's left the same number each time, it's just n squared plus 4. Right, let's have a look at a slightly different one then. One more for higher, and then I'll go through these answers for foundation, and we can have a go at some on higher as well. 8, 15, 24, 35. So let's have a look. What pattern have we got here this time? So we're starting off to get from 8 to 15, we had 7. To get from 15 to 24, we had 9. And to get from 24 to 35, we had 11. So it's not a linear sequence. It's not going up or down by the same amount each time, but there is that same second difference there. So we're adding 2 each time on our second difference again. So same thing. Once we've found that second difference, we have to half it. So halving the second difference to find our number in front of our n squared. Well, again, half of 2 is 1. So it's just going to be 1n squared again. Obviously, if it was 4 there, you'd have 2n squared. If it was 6, you'd have 3n squared, etc. So again, because it's just 1n squared, we just take away our square numbers from our sequence. So 8 take away 1, 15 take away 4, 24 take away 9, and 35 take away 16. Now this time, this doesn't leave the same number each time. All right, 8 take away 1 is 7, 15 take away 4 is 11, 24 take away 9 is 15, and 35 take away 16 is 19. So what this does leave here is a linear sequence, exactly the same sort of question as what foundation students are currently looking at. So we then need to find the nth term of that linear sequence, exactly the same as the examples we've just been through, which is how it sort of follows on and builds up. So it is important that we can do that. So this one, I'm not going to go through it because we've just been through a couple. That 7, 11, 15, 19 goes up by 4 each time. So it's 4n. The one before 7 would be 3. So it's 4n plus 3. So then we just need to add that linear sequence onto the end of the n squared that we've just found. So our actual nth term will be n squared plus 4n plus 3. Okay. Now, the only difference here is if we don't get a second difference of 2, if you got, say, a second difference of 4 and you had to half it to get 2n squared, when you're subtracting it, you'd have to double those square numbers. So we'd take away 2, 8, 18, 32 instead. If we got a second difference of 6 and we had to half it to get 3, we'd have to times those square numbers by 3. So we'd take away 3, 12, 27, 48. Okay, that's the only sort of difference there. Right. So hopefully the foundation students have had a chance to have a good go at those 16 sequences there to find those nth terms. So we're just going to have a look at those answers now. So there, what we should have got there. So for the first one, we could have 1n plus 3, perfectly acceptable if you put 1n or just n plus 3, 2n plus 1, 10n minus 6, 4n minus 1, 5n minus 4, 7n minus 1, 3n plus 6, and 4n minus 4. And then on the other side, they've written them in that other sort of notation that I mentioned after. But again, if you've written minus 1n plus 20, minus 2n plus 17, minus 5n plus 50, minus 2n plus 10, minus 1n plus 0, minus 8n plus 58, minus 5n plus 10, or minus 6n plus 8. They're all perfectly acceptable answers and will get marked correct in your exam. Okay. Right. If there's any issues with any of those, anything wants me to quickly run through, just pop it in the chat and I'll answer any questions. Okay. But just for a bit more practice then, a bit of a mixture there for the foundation to still have a go at, and then a couple of questions there for the higher. Okay. Yeah, so just have a go at those. I'll probably miss out question 1 on the higher because they are just our square numbers, 1, 4, 9, 16. So maybe just start from question 2 if you're having a go at those higher ones and see how we go through those. Any issues, just pop it in chat and I'll answer them as we go. I'll give you 4 or 5 minutes, just have a bit of a quick practice on these. All right, and then we can have a look through. Okay then, guys, so there are the answers that we should have got. All right, so you can see there mixture on the foundation of both ascending and descending sequences. So 2n plus 3, 15 minus n, 9n minus 9, 4n plus 5, 5 minus 5n, etc. And again, for those descending ones, if you put minus 1n plus 15 or minus 5n plus 5 for number 5, perfectly acceptable and will get you 2 marks. Okay. The higher, we said miss out on question 1 because it's just a square number, so it would just end up with n squared. Second one, when we took it away, we should have just got all negative 2s, so we should end up with n squared minus 2. Third one, hopefully there we should have spotted that we had to double our square numbers, and when we take them away, we get all zeros, so we could have got 2n squared plus 0. And then n squared plus n squared minus 2n, etc. All the way up to question 8, which gets a little bit tricky because it is descending there. Starts to have that minus 2n squared. So if you have got minus 2n squared plus n plus 100, again, perfectly acceptable and will get you 4 marks. No sorts of questions in the chat that I've seen. So hopefully everyone's been absolutely spot on with this. Okay. I hope it's been really useful. It does tend to come up, all right, quite a lot every year over the 3 papers. Can come up on any paper because realistically, looking at it, the calculator doesn't really help you with this. So it can come up. They do like to put it on the calculator papers because they know that the calculator is actually not going to be that much help in working this out. So it doesn't necessarily have to be a non-calculator topic. It could come up on all 3 of the papers. Same with the higher on the quadratic nth term there. Calculator, not really that much help there. Maybe just to stop you making some silly mistakes with negatives potentially that it could be used for, but there's no sort of like method for doing it on a calculator as such. So it could come up on any paper. Foundation worth 2 marks, higher tends to be worth 3 marks. Okay, that extra step there to find your n squared. Hope that was really useful. Any sort of questions on this, please don't hesitate to just let me know or ask your class teacher and they'll be able to go through it with you. Okay. Quick reminder about homeworks before we leave. Homeworks, past papers, due in whenever your class teacher has told you to. I know a lot of them are due in tomorrow for the first one, including my own group. All right, so working through those alongside any revision guides and pinpoint stuff that has been set as well. Right, if there's any further questions that anyone wants to just pop in chat, then thank you very much for attending. Have a good evening. I hope it's been useful.